March 1944, Rechlin-Lärz Airfield, Mecklenburg, Germany. The systematic study of captured enemy aircraft had become a vital part of the Luftwaffe's technical intelligence operations. At their testing center Rechlin, the Reich's leading facility for aircraft evaluation, teams of engineers and pilots worked tirelessly to uncover every advantage held by the Allies in the air war. What they uncovered in early spring 1944 would drastically change a perception of American industrial capability and the direction of the air conflict over Germany. The captured P-51 Mustang arrived at Rechlin on March 6, 1944, transported by rail from a crash site near Brandenburg. The plane had been shot down 2 days earlier during the first American fighter escort mission to Berlin. The pilot had died on impact, but the airframe was largely intact, offering German technicians a most complete example yet of the aircraft rapidly transforming the balance of power in the skies over the Reich. Hermann von Bombach, who served in aircraft development and would later command Kampfgeschwader, oversaw the initial assessment. The young American pilot's navigation charts, still in the cockpit, traced a route from an airfield at Debden in England to Berlin and back, a distance of over 1,000 miles round trip. The technical evaluation began immediately. German analysts had been tracking reports of intensified American fighter activity deep inside German territory, but official assessments maintained that single-engine aircraft lacked the range to escort bombers to Berlin. The distance from English bases to the German capital was roughly 560 miles one way. Conventional fighters, even with drop tanks, could not carry enough fuel for such missions while maintaining combat readiness. These conclusions had been based on studies of previously captured P-47 Thunderbolts and P-38 Lightnings, both of which showed limited penetration into German airspace before fuel shortages forced them to turn back. The events of March 4 and 6, 1944 shattered those assumptions. On March 4, P-51 Mustang from the 4th Fighter Group, flying their first mission in the new aircraft after switching from P-47s just days earlier, escorted a small bomber formation to Berlin. Weather and communication problems limited effectiveness, with only 32 bombers reaching the target, but the significance was undeniable. American single-engine fighters had reached Berlin, fought German interceptors, and returned safely to England. 2 days later, on March 6, roughly 660 bombers attacked Berlin in daylight, escorted by more than 150 P-51 Mustangs along with P-38 and P-47 groups. The escorts engaged Luftwaffe fighters directly over the German capital and stayed with the bombers all the way home. This was not a fluke or isolated success. The Americans had solved the escort range problem. General Major Adolf Galland, General der Jagdflieger, and one of Germany's most celebrated aces with over 100 victories, flew missions during this period despite his administrative post. Encountering P-51s over central Germany, he immediately grasped the implications. His combat reports, submitted through official channels, confirmed that American fighters were operating at full combat capability above Berlin, engaging aggressively with no sign of fuel conservation. They had reserves. This contradicted all Luftwaffe intelligence assumptions about U.S. fighter endurance. Galland emphasized the P-51 superiority at high altitude, where it outperformed both the Messerschmitt Bf-109 and Focke-Wulf Fw-190 in speed and maneuverability above 20,000 feet. The Rechlin evaluation focused on discovering how the Americans had achieved such range. Technicians measured the P-51B's internal fuel capacity, 2 wing tanks of 92 gallons each, 184 total, plus an 85-gallon fuselage tank behind the cockpit, added recently in production to extend range. Total internal fuel, 269 gallons. The Packard-built Merlin engine, a licensed version of the Rolls-Royce Merlin that revolutionized the Mustang high-altitude performance, consumed 60 gallons per hour at economy cruise and about 75 at normal power. Using these figures, German engineers calculated a total endurance of 3.8 hours. At a cruising speed of 300 miles per hour, the aircraft's range was roughly 1,140 miles, barely sufficient for a Berlin round trip, leaving no margin for combat. Yet combat reports showed prolonged engagements, 15 to 20 minutes of dogfighting before returning to base. At combat power, the Merlin consumed over 100 gallons per hour, a rate that should have left no fuel for the return leg. The calculations didn't explain what the Germans were witnessing. German pilots had been witnessing the phenomenon in combat. The explanation emerged when technical inspectors examined the Mustang's wing structure more closely. The P-51B incorporated standardized hardpoints beneath each wing, designed for external stores. These mounts included fuel line connections, clear evidence they were intended for external fuel tanks. Drop tanks were not an innovation in themselves. The Luftwaffe had used them since the Battle of Britain. The Bf-109 commonly carried a 300-liter tank, and the FW-190 routinely employed one for long-range sorties. These detachable tanks allowed aircraft to carry extra fuel externally and then jettison them before combat to reduce drag and weight. Every major air force used the same principle. The real question was not whether the Americans had adopted drop tanks, but what their capacity was, and how they were producing enough to sustain continuous missions deep into Germany. Luftwaffe intelligence immediately began searching for evidence. Analysts mapped the probable jettison zones based on air battle reports from German fighter units. Pilots typically released their external tanks once engaged, as the drag hampered maneuvering. Within days, search teams, composed of Wehrmacht personnel and Hitler Youth volunteers, scoured fields and forests northeast of Berlin. Most wreckage they found was mangled or shattered on impact, but two relatively intact examples reached Rechlin within 3 days, having come down softly in wet soil and winter wheat. Those captured tanks appended German understanding of American industry. The containers were cylindrical, about 108 inches long and 22 inches wide, with an estimated capacity of 108 U.S. gallons, roughly 400 liters. A pair of such tanks would supply 216 additional gallons, bringing the P-51's total fuel capacity to 485 gallons. At cruise settings, that translated to roughly 6.7 hours of endurance and a range exceeding 2,000 miles, ample for the Berlin raid with generous reserves for combat. The range mystery was solved, but the tank's construction astonished the engineers even more. They weren't metal. Running a hand across their surface revealed a strange texture hidden beneath the silver paint. When technicians scraped a patch near the tail cone, they exposed multiple layers of heavy paper, each about 0.5 millimeter thick, laminated with a resinous adhesive. The design was deliberate and refined. The nose and tail cones were made of overlapping paper sections molded together like papier-mâché, their seams forming faint ridges. The central cylinder was seamless, wrapped continuously in bonded layers. Fuel fittings were of brass, precisely machined and tightly sealed. Inside, the surface was coated with a cellulose-based lacquer to resist aviation fuel corrosion. Material specialists examined the find in detail. The paper proved to be kraft paper, made through chemical pulping to yield extremely strong cellulose fibers, the same material used in heavy-duty shipping cartons and industrial packaging. The adhesive turned out to be a resorcinol formaldehyde resin, a thermosetting compound whose heat-cured bonds were stronger than the paper itself. At least 12 laminated layers were identified, oriented in alternating directions for cross-grain strength. Simple wooden baffles were installed inside to reduce fuel slush during maneuvers. The entire structure was clearly standardized for rapid mass production. The finished tank weighed about 80 pounds, slightly more than a smaller aluminum version, but its advantages were strategic. The revelation struck the Rechlin engineers immediately. The Americans were building fuel tanks from non-strategic materials. Paper, wood, and resin required none of the aluminum or steel that were growing scarce across Axis economies. Production demanded no metal-forming tools, no welding, no specialized labor. Any paper mill or packaging plant could make them with minimal retooling. The United States had hundreds of such facilities. If even a fraction of its paper industry had been redirected toward this purpose, the scale of output was virtually limitless. Output could reach thousands of units weekly. The tanks bore no serial numbers, no factory markings, nothing to suggest limited manufacture. They were commodities, mass-produced and entirely expendable. Intelligence analysts quickly began assessing the scale of the American paper industry. Before the war, the United States had produced roughly 12 million tons of paper annually, with output rising further during wartime mobilization. Diverting even 1% of that capacity to drop tank reduction would yield over 100,000 units per month, far more than needed for all P-51 operations combined. The only potential limitation was not raw materials, but the number of facilities and workers available for assembly. Yet this was precisely the kind of work that could be performed by semi-skilled labor after brief instruction. To the German planners, the paper tanks represented an almost alien level of industrial efficiency and resource management. Further study revealed more about the design and operational use. They were strictly single-use. The resorcinol resin, though producing strong bonds when cured, gradually broke down after prolonged contact with aviation gasoline. Reports from captured American pilots confirmed that these tanks had to be filled immediately before takeoff and could not remain full for more than a few hours without leaking. This restriction posed no problem in practice. Fighters were fueled just before flight, used the tanks for a few hours, and discarded them once empty. The disposable nature simplified logistics. No retrieval, cleaning, or repair was necessary. They were meant to be used once and forgotten. German analysts also observed the color-coding scheme. Paper tanks were painted silver, while metal ones were gray. This distinction allowed ground crews to identify tank types instantly during refueling operations. The silver paint additionally reflected sunlight, reducing heat absorption and minimizing fuel evaporation or vapor pressure at altitude. Every element of the design reflected deliberate engineering for practicality, scalability, and field use. By late March 1944, German intelligence traced the innovation's origin to Britain. In 1943, the British Air Ministry had ordered the creation of impregnated paper fuel tanks to conserve aluminum and other strategic metals. The Boer-Scott Corporation, leveraging its expertise in paper manufacturing, developed the process. The tanks entered service with IAF fighter squadrons later that year. The U.S. Army Air Forces soon adopted the design, with multiple factories in Britain and America producing them for Allied air groups. What began as a British response to material shortages had become an American triumph of mass production. The implications extended far beyond aviation fuel tanks. German engineers initiated a broader technical review of captured Allied equipment to identify similar examples of industrial innovation. The findings were consistent. American material was not always technologically superior in isolation. German optics, small arms, and metallurgical engineering often remained unmatched, but U.S. equipment excelled in reliability, uniformity, and quantity. The American system emphasized producibility over perfection. Every component was designed from inception for assembly line manufacturing by semi-skilled labor using standardized tools. Parts were interchangeable across units without hand fitting. This stood in sharp contrast to German methods. German weapons and machinery were often masterpieces of precision, each built with exceptional craftsmanship. But such excellence required expert labor, specialized machinery, and time, resources Germany could not scale indefinitely. Production bottlenecks were inevitable. The Luftwaffe's engineers realized that while German technology produced superior individual machines, the Americans produced sufficient machines in overwhelming numbers. In industrial warfare, it was quantity, not refinement, that proved decisive. The P-51 Mustang production history embodied this truth. North American Aviation had designed the first Mustang prototype to meet a British requirement in 1940. The prototype, designated NA-73X, was completed just 117 days after the contract was signed, one of the fastest concept-to-flight timelines in aviation history. Its maiden flight occurred on October 26, 1940. By 1944, production was divided between two plants, the Inglewood, California facility, averaging 364 aircraft per month, and the Dallas, Texas facility, which added hundreds more. Combined, the two plants produced an average of 574 Mustangs per month during 1944. Production continued to accelerate throughout the year, reaching a peak of 881 aircraft in January 1945. Each P-51 contained roughly 15,000 individual components supplied by hundreds of subcontractors across the United States. The Packard-built Merlin engines were manufactured in Detroit at rates surpassing 300 per month. Final assembly of a P-51D required about 22,000 man-hours of labor, yet the assembly line system meant that finished aircraft rolled out every few hours. At peak efficiency, a new Mustang left the factory roughly every 2 hours. The magnitude and coordination of this process exceeded anything achieved in Germany. Messerschmitt and Focke-Wulf together produced around 600 fighters per month in early 1944. Even under emergency programs and with forced labor, German aircraft production never matched American volume. The resource imbalance was equally striking. American aluminum output in 1944 reached roughly 1.25 million tons, about 2.5 billion pounds annually, an enormous leap from the 164,000 tons produced in 1939. German aluminum production, by comparison, peaked near 250,000 tons yearly and declined further as bombing-crippled plants and bauxite sources were lost. The United States possessed nearly 10 times Germany's aluminum capacity. The American choice to build drop tanks from paper rather than aluminum was not a matter of shortage. The U.S. could easily have produced all tanks in metal. Paper was selected because it was cheaper, required no critical manufacturing machinery, conserved aluminum for other uses, and could be produced faster by less skilled labor. This was optimization through abundance, not desperation. The psychological shock of these discoveries rippled through Luftwaffe technical and operational circles. The paper tank became a symbol of the United States' industrial dominance and the enormous gap in resources separating the combatants. Captured examples were displayed at technical briefings across the Reich. Fighter trainees were shown the tanks and asked to calculate their strategic meaning. The conclusion was inescapable. American fighters could now escort bombers anywhere over Germany. The Luftwaffe previous defensive doctrine, waiting for Allied escorts to turn back at fuel limits, was obsolete. To reach the bombers, German interceptors would now have to fight through a wall of long-range escorts, a battle of attrition Germany could not endure. Galland repeatedly presented this operational reality to senior Luftwaffe leadership during the spring of 1944. The P-51, he warned, outperformed all German types above 20,000 feet. It was faster than the Bf-109 at altitude and more agile than the FW-190. With its extended range from drop tanks, it could accompany bombers for the entire mission. The era of unescorted daylight raids was finished. Every attack required punching through Allied fighter cover, and losses were rising sharply. In January 1944, the Luftwaffe lost about 90 fighters while claiming roughly 150 Allied aircraft destroyed. By February, German losses had grown to about 160 against 230 Allied. The pattern was unmistakable and untenable. The Allies could replace their aircraft and crews faster than Germany could destroy them. By summer 1944, the full weight of American escort capability was being felt. The 8th Air Force carried out deep penetration raids almost daily whenever weather allowed. Mustangs provided seamless escort from England to targets across Germany and back. German day fighter losses became catastrophic. In June 1944, approximately 350 day fighters were destroyed defending the Reich. July saw losses climb above 350 single-engine aircraft in the West alone, an attrition rate of 31.2% for the month. August brought similar devastation with 36% attrition. At these rates, veteran pilots were dying faster than replacements could be trained. The new pilots arriving from flight schools possessed perhaps 150 total hours compared to 300 or more for their American counterparts. Some German replacements had barely 30 hours on type before entering combat. The widening experience gap, combined with inferior numbers and constant P-51 presence, made daylight missions increasingly suicidal. Galland submitted continual reports to Hitler and the Wehrmacht High Command through this period. His September 1944 memorandum stated plainly, the Luftwaffe could no longer win the air war. Germany lacked the fuel, aircraft, and trained personnel to contest Allied air supremacy. The Allies' ability to replace every loss overwhelmed any possible German counteraction. The only rational course was to conserve resources for defending vital areas and hope for a political solution before total collapse. By late 1944 and into 1945, the paper drop tanks continued to rain down across the German countryside, humble symbols of the industrial power that had rendered the Reich's air defenses obsolete. German civilians soon learned to recognize the distinctive silver cylinders scattered across fields and forests. Early reports often mistook them for unexploded bombs, spreading panic until military authorities clarified they were empty fuel tanks. Civil defense organizations circulated instructions explaining that the silver objects falling from Allied aircraft were harmless. The psychological effect was unmistakable. Civilians watched Allied formations cross the sky in such numbers that their contrails laced the heavens, discarding fuel tanks as casually as trash. It underscored a bitter truth. While the Allies had resources to waste, Germany struggled for every liter of fuel and scrap of aluminum. Technical intelligence continued evaluating captured American equipment through 1944, but the emphasis shifted from assessing capabilities to documenting the sheer industrial gap between nations. Could Germany build similar paper tanks? Technically, yes. German chemists could synthesize appropriate resins, and paper mills could manufacture kraft paper. The process itself was straightforward. Practically, however, the answer was no. Germany's chemical industry was already overstretched, producing synthetic fuels, explosives, and essential war materials. Diverting resin production for non-critical applications was impossible. The paper industry, too, was fully devoted to military demands, maps, documents, and packaging. Most decisively, there was no longer a need. By late 1944, fuel shortages were grounding much of the Luftwaffe. Pilot training hours were slashed to the bare minimum. Combat operations were restricted not by aircraft numbers but by lack of aviation fuel. Building long-range drop tanks was meaningless when there was scarcely enough fuel for local defense sorties. The irony was bitter. The Americans had solved the range problem with paper tanks at the very moment German pilots were grounded for lack of fuel. Different resources, different problems, and entirely different outcomes. The Americans had abundance, more planes, more fuel, more pilots, more aluminum, more factories, and enough surplus capacity to perfect efficiencies like disposable tanks. Germany was fighting a war of scarcity against an opponent untouched by such limits. By January 1945, the war's end was inevitable. Soviet forces were nearing the Oder River, less than 50 miles from Berlin. In the west, the Allies had recovered from the Ardennes offensive and were advancing toward the Rhine. The Luftwaffe could offer only scattered resistance, crippled by fuel shortages and devastating losses among its pilots. The technical analysis of Allied aircraft continued at Rechlin, but it had become an academic exercise. The findings were filed away for history rather than for strategy. The final comprehensive report on the P-51 and its drop tanks was completed in late January 1945. It detailed every technical element of the Mustang's range, the construction of its tanks, production estimates, and combat implications. Its conclusion was blunt. The P-51 Mustang, equipped with expendable paper tanks made from non-strategic materials, had rendered Germany's heartland indefensible against daylight bombing. Germany no longer possessed the means, industrial, logistical, or human, to contest Allied air superiority. The report was archived in the Reich Ministry before the war's collapse. Whether senior leaders read it is uncertain. By then, such documents merely confirmed what everyone at the front already knew. The Luftwaffe, which had ruled the skies of Europe in 1940, was by early 1945 reduced to sporadic, desperate sorties, hoarding the last drops of fuel for missions that could no longer alter the outcome. American fighters roamed the air unchallenged, escorting bombers, strafing trains, and hunting targets at will. Each silver paper tank tumbling from the sky served as a quiet symbol of the industrial gulf that had decided the air war. At Rechlin's June 1944 exhibition, captured Allied aircraft were displayed to Luftwaffe personnel, P-51 Mustangs alongside B-17s, B-24s, P-38 Lightnings, Lancasters, Mosquitoes, Typhoons, and Spitfires. Thousands of German pilots and technicians walked among them, studying their rivals' machines up close. The paper tanks were featured prominently, accompanied by diagrams showing their structure and strategic effect. The display was both technical education and grim reminder. It demonstrated the precision, standardization, and unimaginable scale of Allied production. Through these exhibits, Luftwaffe personnel could physically see the industrial reality that had already overwhelmed them. Every rivet and uniform component told the same story. The Allies had built an arsenal beyond imitation. Kampfgeschwader 200, the Luftwaffe Special Operations Unit tasked with flying captured enemy aircraft, operated several P-51s throughout 1944. These Mustangs were used for evaluation and familiarization flights, giving German test pilots first-hand experience of the aircraft that had conquered their skies. To experience directly the performance qualities that made the Mustang such a formidable fighter. Reports from Kilogram 200 pilots consistently praised its superb visibility, particularly in the later P-51D model with its bubble canopy. They noted the aircraft's stability, crisp handling, and outstanding high-altitude capability. The Packard-built Merlin engine delivered smooth, dependable power across all regimes. Most remarkable was its range. With internal fuel and drop tanks, AP-51 could stay aloft more than 6 hours, missions far beyond the reach of German single-engine fighters, even when fitted with external tanks. The insights gained at Rechlin influenced Luftwaffe defensive tactics during the war's final year. Once it was clear that American escorts could accompany bombers from takeoff to target and home again, controllers tried to mass fighters at specific intercept points to achieve brief local superiority. This demanded flawless timing and coordination, as scattered units had to converge into large formations. Chronic fuel shortages and communication delays made such efforts unreliable. Even when successful, attacking through swarms of P-51s inflicted heavy losses. The balance of power had reversed. In 1943, unescorted bombers had been slaughtered. By mid-1944, it was the German interceptors that suffered catastrophic attrition. After the war, the paper-drop tanks themselves became rare collector's items. Most were crushed on impact or destroyed by Allied ground crews to prevent reuse. Their expendable nature gave them little value at the time, but a handful survived as museum relics. The National Air and Space Museum in Washington preserves several examples beside the Mustangs they once served. Each placard lists their composition, laminated kraft paper with phenolic resin, their makers, such as Scott, and their 108-gallon capacity. What those placards omit is the months of studied German engineers devoted to these humble artifacts, and how deeply the discovery affected them. They knew they were not examining an advanced weapon. The paper tank was intentionally simple, a product of ingenuity through industrial might. Its message struck harder than any new engine or gun design could. The Allies possessed such abundance that efficiency, not scarcity, dictated their innovations. They built tanks of paper because they had limitless paper, limitless resin, limitless factory space, and limitless fuel to fill them. German engineers grasped the implication instantly. They were not fighting an opponent forced into substitution. They were fighting one wealthy enough to choose it. Post-war interrogations of Luftwaffe officers often returned to this realization. Asked when they knew Germany had lost, many cited the spring of 1944, when long-range escort fighters first appeared over Berlin. Hermann Göring, questioned after the war, admitted that the arrival of those escorts dealt a decisive strategic blow. Whether or not his famous remark about seeing Mustangs over Berlin was verbatim, his latest statements all conceded that Allied air superiority, enabled by those long-range fighters, had sealed Germany's fate. The knowledge German engineers gained from analyzing captured P-51s and their drop tank-shaped post-war aviation design. Many of them emigrated to the United States or worked with Allied technical services, bringing with them an appreciation for mass production and design simplicity. The principles they absorbed, standardization, interchangeability, and ease of manufacture, became central to aircraft engineering in the decades that followed. The paper drop tank entered history as a case study in wartime industrial innovation, taught in engineering schools and staff colleges as proof that resource optimization and scale could outweigh complexity. The P-51 Mustang itself remained in service for years, flying with numerous air forces around the world. It saw heavy action again in Korea, excelling in ground attack and close support roles, the same long range and endurance that once carried it over Berlin now carrying across a new generation of battlefields. Outstanding escort fighter in Europe, proved equally valuable in the vastly different conditions of Korea. The P-51 remained in frontline service with several air forces into the early 1980s, a testament to the strength and adaptability of its original design. More than 15,000 Mustangs were built during and just after the war, making it one of the most numerous American fighters ever produced. Today, over 100 still fly, lovingly maintained by collectors and museums worldwide. The sight of a Mustang soaring overhead, often still bearing its wartime markings, recalls the aircraft's decisive role in achieving Allied air supremacy. The greater historical meaning of the P-51 and its paper-drop tanks reaches beyond their immediate tactical impact. They stand as an enduring lesson in industrial warfare, the primacy of production capacity in modern conflict. World War II was not won solely by strategy or heroism, but by output. Victory went to the side that could build more airplanes, ships, weapons, and supplies faster than the enemy could destroy them. The United States achieved industrial mobilization on a scale unseen in human history. At its wartime peak between 1943 and 1944, American factories produced over 50,000 aircraft a year, launched ships by the dozens each week, and turned out ammunition in the billions. This staggering production fed not only U.S. forces but also those of Britain, the Soviet Union, and other allies through Lend-Lease. Germany, despite technical brilliance and a solid industrial base, could not compete with that scale. Strategic bombing, territorial losses, dwindling access to raw materials, fragmented priorities, and inefficient management all eroded its output. More fundamentally, Germany fought a coalition whose combined industrial strength dwarfed its own. Once America's full production capacity joined the Allied side in 1942-43, Axis defeat became only a matter of time. The paper-drop tanks reigning across Germany in 1944-45 embodied this industrial imbalance in the simplest possible form. The Luftwaffe technical analysts at Rechlin studied captured Allied equipment meticulously throughout the war, recording every specification, testing performance, and dissecting materials. Many of those reports survive, giving historians a detailed view of how the Germans understood their adversaries. Their conclusions were usually correct about technical details, but they underestimated scale. They could describe a single P-51 with precision, yet failed to grasp the consequence of 10,000 more exactly like it. That misunderstanding defined the war's outcome. One P-51 was a fine fighter. 10,000 meant unbreakable air dominance. The story of German engineers poring over paper tanks in March 1944 is, in essence, a story about the true nature of industrial warfare. It illustrates that when industrialized nations clash, production capacity can outweigh tactical brilliance. The side that can build faster, replace losses sooner, and sustain output longer wields a decisive edge. This was the painful lesson Germany and Japan absorbed in 1945, and one that shaped military strategy throughout the Cold War and beyond. The capacity to maintain production under stress, train replacements faster than casualties mount, and out-manufacture an opponent remains as vital today as it was in 1944. The March 1944 missions to Berlin, first escorted from start to finish by single-engine fighters, marked the turning point of the European air war. From that moment, no German target lay beyond reach. The bombing offensive could continue with losses low enough to sustain indefinitely. German war industries came under relentless assault. Synthetic fuel plants, ball-bearing factories, aircraft assembly lines, and transport networks were struck again and again under full fighter escort. Combined with Soviet advances from the east and Allied drives from the west and south, this campaign crushed Germany's ability to fight within 14 months of the Mustang's debut over Berlin. Paper drop tank production continued through 1945, numbering in the thousands each month. They equipped not only P-51 Mustangs, but also P-47 Thunderbolts and P-38 Lightnings, vastly extending operational range across all American fighter types. British forces likewise employed the paper tanks extensively. The Royal Air Force's Mustang squadrons relied heavily on them for extended-range missions over occupied Europe and deep into Germany. The efficient production of paper tanks conserved aluminum and steel for other critical uses while providing the endurance necessary for sustained strategic bombing. This careful matching of production techniques to operational needs, favoring efficiency over convention, reflected the broader industrial philosophy that defined Allied success in World War II. Historians analyzing the air war over Europe identify multiple interlocking factors behind the Allied victory: numerical superiority in aircraft and train crews, technological leadership in radar, communications, and navigation, the relentless bombing of German industry and infrastructure, and the cumulative strain of continuous operations that exhausted German resources faster than they could be replenished. The P-51 Mustang and its paper tanks were essential components of this broader system, not the sole cause of victory, but a striking symbol of the industrial logic that powered it. At Rechlin, the Luftwaffe's engineers continued to document every captured example with meticulous care. They recorded dimensions, materials, and manufacturing techniques with a characteristic thoroughness of German technical practice. These reports, preserved in archives such as Bundesarchiv, now offer historians a window into how the German experts viewed Allied engineering. Their evaluations were usually accurate. They correctly recognized American strengths and the soundness of their designs. What they could not counter was the scale of the system that produced them. Recognizing an enemy's advantage is not the same as being able to overcome it. especially when that advantage is grounded in overwhelming industrial and material capacity. The legacy of the paper drop tank endures beyond the war itself. It stands as proof that effective solutions need not be complex. A disposable container made from glued paper, cheap, light, and easy to produce, answered a specific operational need elegantly and efficiently. It was, in every practical sense, good enough. That idea, designing for adequacy rather than over-engineering, became a cornerstone of modern systems engineering. The best design is not always the most advanced. It is the one that fulfills its purpose within available time, materials, and manufacturing capability. This principle, illustrated by the thousands of paper tanks scattered across Europe in 1944-45, remains applicable in both military and civilian technology today. The aircraft that carried them, the P-51 Mustang, remained one of aviation's great success stories, a perfect synthesis of performance, range, reliability, and production efficiency. Its success was a product of many converging factors: North American aviation's aerodynamically refined A-frame, designed by Edgar Schmid, the power and dependability of the Merlin engine, the fuselage fuel tank that extended its reach, and the expendable drop tanks that pushed its operational radius beyond 800 miles. No single innovation achieved supremacy. It was their integration, supported by vast industrial power, that made the P-51 the defining escort fighter of the European air war. 80 years later, the lessons remain instructive. The work done at Rechlin in March 1944 revealed not merely the details of an aircraft, but the structure of a civilization at war. The paper tank showed that the United States possessed industrial capacity Germany could never match, that Allied engineering favored practicality over aesthetic perfection, and that abundance allowed optimization without compromise. These insights, arriving when the war's outcome was beginning to tilt decisively, gave German engineers clarity if not hope. They understood precisely what they faced, but not how to change it. Germany's fate was sealed by forces beyond control of those technicians studying paper and glue. Yet their observations endure as a study in how industrial capacity determines victory in modern warfare. When the war ended in May 1945, the strategic bombing campaign, enabled by long-range escort fighters like the P-51, had shattered Germany's war economy. Factories lay in ruins, transport systems collapsed, fuel reserves were gone, and the Luftwaffe existed in name only. Many causes combined to bring this outcome, but among them stood the ability to escort bombers across all of Germany, an ability made possible by those paper tanks. The few surviving examples became museum artifacts, mute witnesses to the truth they once represented. That victory in industrial war depends not only on invention or bravery, but on the capacity to build, supply, and sustain at a scale the enemy cannot match. The records from Rechlin preserve that story, a story of glue and paper, of fuel and flight, and of the quiet power of industrial mastery.